Today's topic is computer networking basics for cybersecurity professionals or ethical hackers. Computer networking is one of the key skills if you want to be in the field of cybersecurity or cyber forensics. It is essential and it requires lots of understanding of computer networking, which includes in-depth understanding of IP address. For example, what is IP address, who allocates IP address, classes of IP address, IPv4, IPv6, NAT, that is network address translation, TCP IP concepts, OSI model, tools for analyzing network packets and protocols, and OSI model in relation to cybersecurity. So, let us start with the IP address. IP address is comprised of two words, internet and protocol. What is internet? It is a global network that connects billion of digital devices across the world with each other. Or we can say that internet is a global communication system that links together thousands of individual networks such as multiple local area networks. And what is a network? When two or more than two devices are connected with each other, they form a network. I have created one detailed video on basic concepts for computer networking. It is even fit for CBSE class 12 students as well. Therein I have explained what is internet, computer networking, networking devices in detail along with practical oriented approach. I will provide the video link in the description box. Do watch that video for better understanding of today's subject. Now, let us understand what is protocol. Protocol is an established set of rules that determine how data is being transmitted between different devices in the same network. IP address is a unique number assigned to each digital device, be your computer, laptop, phone, etc. IP address enables us to connect and communicate. Imagine an IP address similar to your house address. Without your house address, neither anyone can come to meet you, nor you can receive postal mails at your home. Internet protocol or IP is a set of rules that governs how data is transmitted over the internet. It is a fundamental protocol used for communication over the internet. In simple terms, IP is responsible for routing data packets between different devices on the internet. When you send an email or browse a website or use any internet service, your device sends packets of data to the server, and these packets are routed across the internet using the IP. Each device on the internet has unique IP address, which is used to identify the device and route data packets to it. An IP address is a series of numbers separated by dots, such as 192.168.1.1. The IP ensures that data packets are delivered to the correct address, meaning correct device, regardless of its location on the internet. IP also defines the format of data packets, including the headers and payloads, which contain information about the packet and the data being transmitted. This information is used by routers and other network devices to route the data packets to its destination. So, overall, internet protocol is a crucial part of the internet infrastructure, allowing devices to communicate with each other and enabling the vast array of services and applications that we use every day. We currently use IP address system known as IPv4. It is made up of 32 bits of 4 octets, meaning 8 characters, or you can say 4 groups of 8 bits, for instance 192.168.1.101. So, the numbers between the dots is the decimal equivalent of 8 bits, and IPv6 is the advanced form of IPv4. It is better in terms of complexity and efficiency. Now, what are the classes of IP addresses? There are generally 3 classes, A, B and C, and range is as class A starts from 0.0.0.0 to 127.255.255.255. Class B starts from 128.0.0.0 to 191.255, and class C is 192.0 to 223 to 255. Now you may ask, who assigns IP addresses? These addresses are allocated by the Internet Assigned Numbers Authority, IANA. It is a department of the Internet Corporation for Assigned Names and Numbers, ICANN. So, IANA assigns IP address blocks to the regional internet registries, that is RIR. Who are RIRs? RIRs are organizations that manage the distribution and registration of internet protocol addresses and autonomous system numbers in a specific region of the world. RIR allocate the IP addresses to the internet service providers and other organizations within their respective regions. The RIRs are African Network Information Center, second is American Registry for Internet Numbers, third is Asia Pacific Network Information Center, APNIC, fourth is Latin American and Caribbean Internet Addresses Registry, and fifth is Rezux IP Europeans Network Coordination Center. Are there any types of IP? Yes, public and private. As we know that each device connected to the internet has an IP address, which is a unique identifier used to send and receive data over the internet. So, there are two types of IP addresses, public and private. Public IP address is an IP address that can be accessed directly over the internet and is assigned to your network router by your ISP. So, your personal device also has private IP that remains hidden when you connect to the internet through your router's public IP. So, public IP address is assigned by the ISP to a device that is connected to the internet, such as your computer, router or smartphone or server, and this IP address is globally unique, meaning it can be used to identify the device on the internet. And public IP addresses are used for communication between devices across the internet, such as accessing a website or sending an email. While on the other hand, a private IP address is the address your network router assigns to your device. Each device within the same network is assigned a unique private IP address. And this is how devices on the same internal network, that is LAN, talk to each other. Private IP address is assigned to a device on a private network such as LAN, while public IP address is assigned to router which is connected to the internet. Private IP addresses are not globally unique and cannot be used for communication over the internet. Each device within the same internal network is given a unique private IP address, and these private IP addresses enable those devices on the same network to interact without needing to connect to the internet, meaning locally they can talk to each other. Private IP addresses let devices connected to the same network communicate with one another without connecting to the entire network. For example, 5 people are sitting in a building or in a room, they can talk to each other, but they cannot talk to the people who are outside the room. So, devices communicate with one another within the private network, such as sharing files, printing documents or accessing network resources. Private IPs assist to strengthen security within a specified network. That is the reason you can print papers from your home using a wireless connection, but your neighbors cannot send their files to your printer because they are not connected or they are not part of your internal network. So, to enable communication between a device on a private network and the internet, a router is used. So, router acts as a gateway, meaning it translates between the private IP address on the LAN and the public IP address assigned by the ISP. This process is known as network address translation, that is NAT. To summarize, you can say that public IP addresses are used for communication over the internet, while private IP addresses are used for communication within a private network. The router acts as a gateway between the private network and the internet, translating between the private IP addresses and the public IP addresses assigned by the ISP. Are there any limitations of IP address? Yes, there are. The most significant restraint is that there are not enough IP addresses to cover all the devices. We all have multiple devices, each individual is having 7-8 devices. So, IPv4 system has only 4.3 billion IP addresses, and those are not enough for all of us. Therefore, a system was developed to reuse a group of IP addresses within a LAN, and those numbers are not reusable over the internet. These addresses can be used repeatedly within each LAN, but not over the internet. Therefore, it conserves the number of IP addresses necessary to keep the world connected. So, private addresses include 192.168.0.02, 192.168.255.255. Likewise, we have other categories. You must have seen that private addresses beginning with 192.168.1.1 or 1.10, something like that. If you type ifconfig in your Kali system, or if you type ipconfig in Windows, and this is your private IP that is only usable on the local area network. To communicate over the internet, your IP address must be translated to a public IP using a NAT device, that is your router. Now, there is one more technical term we need to understand, that is DHCP. It stands for Dynamic Host Configuration Protocol. It is a protocol used to automatically assign IP addresses and other network configuration settings to a device on a network. DHCP assigns IP addresses dynamically, meaning you do not get the same IP address each time you connect. Because we understand that each device needs a unique IP address to communicate with other devices on the network, so traditionally these IP addresses were assigned manually by the network administrator, and it was a very time consuming and error prone process. With the help of DHCP, this process is automated, therefore it is faster and more efficient. So, whenever a device connects to a network that uses DHCP, it sends a request to a DHCP server for an IP address, and the DHCP servers assigns an available IP address from a pool of addresses and sends it back to the device along with other network configuration settings such as subnet mask, default gateway and DNS server. DHCP also allows IP addresses to be leased to devices for limited period of time, after which the device must request a new IP address. This ensures that IP addresses are efficiently allocated and there is no confliction of IP addresses within the network. So, overall, DHCP simplifies the process of assigning IP addresses and other network configuration settings to devices on a network, making it faster, efficient and less prone to errors. And because it is automatic and it is dynamic. Dynamic means every time you do not get the same IP address. Most of the time these IP address assignments are on a LAN. Also remember that on LAN we use private IP address. So, when each device is connected to the LAN, it must request an IP address and that device sends the request to the DHCP server that assigns an IP address to that system for a fixed length of time, and that fixed length of time is known as lease. So, each time you connect to the LAN, you likely to receive a different, that is dynamic IP address, because it is changing each time, that is why we call it as dynamic. And but range remains the same, whatever is defined, that is 192.168.0.02, 192.168.255.255. Now, we understand what is NAT, that is network address translation. It is a technique where internal private IP addresses are translated into an external public IP address that can be routed to its destination via internet. If a device on a private network, it may be your home or office, wants to communicate with a device on the internet, it uses a public IP address, and the private network use a different range of IP addresses that are not routable on the internet, meaning they cannot be used for communication outside of the private network or LAN. So, router on the private network acts as a gateway to the internet. So, when a device on the private network or LAN wants to communicate with a device on the internet, the router translates the private IP address of the device into the public IP address that can be used on the internet. And this process allows devices on private network to communicate with devices on the internet without revealing their public IP addresses. And it also allows multiple devices on the private network to share a single public IP address, which helps to conserve IP addresses. So, remember, public IP addresses of the devices inside the LAN cannot use their IP addresses on the internet because they are not unique. And your router functions as a NAT device, allows devices that are on LAN to send request to access the internet, and then it writes that particular device private IP address in a table and converts that private IP address to the public IP address of the router, and router IP address is unique. When this packet returns from its destination, the router looks into the saved IP, private IP into the table of the original request. It forwards that packet to the private IP address of the device that made the original request within the LAN or internal network. I summarize it once again. NAT maps private IP addresses used within a private network to public IP addresses used on the internet. When a device on a private network wants to access the internet, it sends a request to a public IP address. The NAT device, that is your router, intercepts the request and replaces the private IP address with a public IP address, and router further forwards this request to the destination on the internet. And when this packet comes, it is the router which directs that particular packet to the internal device. So, router typically has two network interfaces. One is connected to the private network and another interface is connected to the public internet. So, when a response is received from the internet, router maps the public IP address back to the corresponding private IP address of the device that originally made the request. This allows the response to be routed back to the correct device on the private network. There are multiple technicalities involved in NAT implementation. I will discuss those in some other video. NAT can be implemented using a variety of techniques such as static NAT, dynamic NAT, port address translation called as PAT. Static NAT maps a fixed private IP address to a fixed public IP, while dynamic NAT maps a pool of private IP to a pool of public IP. And PAT, also known as NAT overload, maps multiple private IP addresses to a single public IP address using different ports to distinguish between different private IP addresses. Looks complex? We will talk in some other video. Understand port. Port in a computer networking is a software defined number associated to the computer network protocol that receives or transmits communication for a specific device. And if it is a computer hardware such as desktop, laptop, then port is a jack or socket that peripheral hardware plugs into. So, ports are kind of sub address. IP address is the primary address and port is the sub address. Consider IP address as your street number and port number as your apartment number. So, IP address connects us to the right host and the port connects us to the right service. For example, HTTP service that is used in the website is running on port number 80 and there are total 65,536 ports, and first 1024 ports are referred to as common ports, and there are few ports that should be on your tips, especially if you are into cybersecurity or forensics, or if you are a network engineer. Now let us understand about a very good tool called as Nmap. This tool is used to check the open ports in a computer or a server. It helps in knowing which ports are open, which services are running on the target device. Ports which are not in use should be kept closed as a security preventive measure. And there are few communication models in computer networking. What are those? These models are used to describe the communication process between the devices. Popular models are OSI and TCP/IP. OSI stands for Open Systems Interconnection model. It is a conceptual model that defines a 7-layered architecture for communication between devices. Layers are physical, data link, network, transport, session, presentation and application. While TCP/IP model called as Transmission Control Protocol or Internet Protocol. This is a protocol suite that is widely used for communication over the internet, and it has 4 layers: network access, internet, transport and application. Sometimes people do compare OSI and TCP/IP models, although they are different, but even then they are being compared. TCP/IP model is simpler and more practical, while OSI is more comprehensive. And there is another model called as hybrid model. Hybrid model combine feature of both OSI and TCP/IP. These models often have fewer layers and are more practical for certain types of networking. Each of these models provides a framework for understanding the communication process and enables devices to communicate with each other in a standardized way. Now let us understand the OSI model in detail. It is a conceptual model and it defines how data communication occurs in a networked computing environment. It was developed by the International Organization for Standardization, that is ISO, somewhere in 1980s, and purpose was to facilitate communication between different types of computer systems. OSI model is composed of 7 layers, each of which defines a specific aspect of data communication, and the layers are application layer. First one, this layer provides services that enables application programs to communicate with each other over a network. Second one is presentation layer. It handles data formatting and encryption to ensure that data can be read and understood by applications on different systems. Third one is session layer. This layer establishes, manages, terminates sessions between applications on different systems. And fourth one is transport layer. This layer provides reliable data transfer between systems, including error detection and recovery. Fifth one is the network layer. It provides routing and addressing the functions, including the fragmentation and reassembly of data packets. Sixth one is the data link layer. This layer provides error-free transmission of data frames over a physical network. And seventh is physical layer. Physical layer defines the physical characteristics of the network, such as cables, connectors, or the signaling methods which are being used to transmit the data. So OSI model is a reference model, meaning it does not specify the actual protocols or technologies used to implement each layer. Instead, OSI model provides a framework that allows different protocols and technologies to interoperate in a standardized manner. To help you remember the various layers of this model, there are some mnemonics which are being used. So if we start from top to bottom, we can take first letter of each layer, say A, P, S, T, N, D and P. So many people remember these layers by using mnemonic device, and popular one is all people seem to need data processing. So now we talk about OSI model from a cyber security perspective. There are attacks against each protocol in this model, and they can be categorized as for example, application layer. So, this layer generally includes applications such as browser, word processors, etc. So, exploit attacks are mostly performed on it. In these type of cyber attacks, hackers embed the malicious code within the application, and further with the help of their malicious code, they take control of the application and the entire system. While at the presentation layer, popular attack is phishing or sending spam emails with malicious links. And on session layer, the most important attack is hijacking. Hijacking is where an attacker can take over an existing session established legitimately by the user. And at the transport layer, hacker often does their reconnaissance. At the network layer, attackers can conduct man in the middle attack, where they place themselves between a legitimate user and the server, and thereby eavesdropping on the traffic and possibly even altering it or modifying it. While at the data link layer, attackers can spoof the MAC address, the globally unique address stamped on every network device, and finally the physical layer, sniffing is done on it. Sniffing is the practice of watching and analyzing network traffic. There are multiple network traffic sniffers or open source tools such as Wireshark and sniffers. So, this is about cyber security and computer networking, basic understanding like the terminologies, technologies which we use or which we require if we study cyber security or cyber forensics. And it is very interesting and useful topic, and it will be used all the time. So, make sure your basics are good. If you have any query on the same topic, you may write in the comment box, and if you are looking for any specific topic, that also you may write in the comment box. I will try to make another useful video for you.